Hey guys, so I was doing some optimization of a couple of functions in one of my libraries the other day, and this was a great example of why it's so important to test and measure when you're trying to do optimizations, because it's very easy to mislead yourself into thinking that what you're doing is going to make things run faster, but it may actually make things run slower. And this was a perfect example of that situation. So let me show you what I was doing, what I went through, and what happened, and kind of show you why it was so important that I was trying to test that I was going to actually make things faster, not slower. So let's jump into it. So the library I'm working with here is just a string library that I've got, which just a variety of string convenience functions. And the functions I was working on are reading from a file. So we've got two variations here that we want to do. I want to read the lines in the file into an array of strings, or I would like to just read the whole contents of the file into a single string. So what I've got here is my initial implementation, and I've got some tests, so I already know that this implementation works, but I just kind of threw this one together as I know this is the simplest way I can think of to make it work. And so I know it works because I've got tests that check that it works. But on second glance at this thing, I went, I think this might not be the fastest. So since I've got tests that make sure that it works, why don't we try and see if we can make it faster? So what I did was I created another test that's gonna check the speed. It's gonna compare the speed of one routine to another. So basically I just have two subroutines that do the work that I'm trying to measure. They don't take any arguments and don't return anything. They just kind of do the work that I'm trying to measure. And so one is going to, I've got a little bit of setup code here before where I'm taking some text, and so I just got some dummy text from somewhere that just fills up, so I have something to work with. That I'm just going to fill up a file with this just nonsense text, so I've got something to work with for my measurements. So I'm going to put that into a file, and then each of these subroutines is just going to go read the contents from the file. And then this is just going to measure which one and compare the speed of them, and it's going to do it 50 times and give me an average, and then make sure that the one is faster than the other. So that's the basic test here that we're going to do. So to start with, we'll start with the read file lines, because my initial implementation was for reading the whole file was just we'll read all the lines and put them back together into a single string with new lines. So the real bulk of the work here is being done by this function anyway. So we'll start with trying to optimize that. And so the way that we're going to do that is I'm just going to take the initial implementation, I'm going to copy it into a new function, and this is going to be my kind of reference implementation of, let's try and make it faster than this. So if I can make it faster than this, then the test will pass, and we'll be happy because we've done some optimization. So that's what we're going to do. So we'll jump over, and we will run the tests. And I'm just going to filter it so it's just running the tests that are checking the speed. So it's going to compile and run these tests, and we'll see how we're doing here. So we're just going to test that these two different functions are faster than their initial implementations. And these ones, they pass this time around, but we would kind of expect that it's probably going to be random because they basically have the exact same implementations, right? So as you can see, well, this time it failed because they basically have almost identical timings because they're identical implementations, and so that's kind of what we expect. So what we want to try and do now is Now we're going to try and work in this function and see if we can make it go a little faster. And so because I was looking at this and I'm going, okay, well, we're doing, there are things that are kind of really expected to be slow. Doing file I/O is one of those things that is probably slow because we got to go all the way to the disk and read that into memory and then read that right. So processing data from a file is generally going to be slow. And then not only that, we're looping through the contents of this file twice. We're doing it once to figure out how many lines are in the file, allocating our array, and then going through and doing it again to actually fill up the array. So we're doing I/O here, and we're doing it twice. So I thought, well, maybe we can get this down to only doing it once. And so let me go grab the implementation that I was going to try. We'll copy that in here. All right. So in this implementation, what I'm going to do is this time I'm going to only loop through the contents of the file once. I'm going to collect that up into a single string, so when I get the next line, I'll just append that to my string, and we'll just keep going. So now I'm only doing I/O once per line in the file instead of twice. So hopefully that should be faster. But this is why we test, because now I'm going to save, jump back over, and run my tests. And we'll take a look and we'll see what happens. So hopefully that's faster, right? Now we're only looping through the file once. That should be faster. So what do our tests say? So this is the one we're working on right now, and it's saying that it took 0.1 seconds to read that file, where my reference implementation only took 1 millisecond. So we're going from a millisecond to a tenth of a second. Well, now we're only looping through the file once now. Why is this taking 100 times longer now? That seems strange. And this is why you test these things. Because the naive thought is, well, now we're only doing this loop once, and our I/O is slow, and now we're doing half as much I/O. But what's happening is this string is reallocating its space every time it has to append the new contents to the string. That allocation of memory and copying, because it's got to allocate new memory, copy the string into it, and it can probably do some optimizations about how pointing the variable at the new memory instead of doing a copy and copy back. But that is still, that allocation of memory is actually really slow. But the initial thought process doesn't catch that, because I'm looping over and doing something slow twice. Let's see if we can only do it once. But in so doing, now I'm doing something slower every time in the file, instead of only reading the file's lines. Instead of just reading the file, I have to do it twice, but that's much faster than trying to do memory allocations and copies. So, and we can look at doing the way we do similar operation for reading the whole contents of the file. So what we were doing is, I was just reading all the lines into an array and then putting the array back together. And I thought, well, if that operation was going to be slow, well then this was really going to be slow, because not only am I looping through the contents of the file twice when I don't really need to. I could have been putting the string together the same way the whole time anyway. So in order to do this one, so we've copied the implementation of read file lines in there as well, so that this is probably going to be a little bit faster because we're avoiding that extra function call overhead. But really we just kind of want to optimize this function without having to worry about whether the other function got optimized. We want the reference implementation of the whole thing, not just this one line. So we've got read file lines and then this other join to put things back together. So we're going to start from there. And so I had basically the exact same thought process of like, what am I doing this intermediate array for when I could just be constructing the string on the fly as I go and not having to loop through the file twice. So we'll grab the implementation that I'm going to try, and we've got our reference implementation here, and we'll run it and we'll see if things go faster, because that's our plan, right? Is without looping through the file and without constructing this intermediate array, things should go faster. But what does the test tell us? The test tells us, well, now it actually takes twice as long. And again, for the same reason, but if we weren't testing this, our naive thought process about file I/O is slow, let's try not to do it more than we have to, is actually introducing something that's even slower, and it's reallocating that string on every line, which is slower than just reading the line. So what do? Well, now we have an alternate implementation. The whole plan was, well, let's just make sure it's faster than some naive implementation. Well, it turns out the thing we thought would be faster is actually the slower naive implementation. So let's just swap them. And we'll now have some timing tests of, well, at least we know we don't ever want to be slower than that. So now we've got some new tests that make sure our implementation isn't slow. And we found out that the implementation we started with was actually pretty good. So we just grab the old implementation, put it into our function, grab the new implementation, and put it into our test, and do the same thing for the other function. Grab that one. Cut that. Paste there. Jump back over here, rerun our test, make sure everything's nice and hunky-dory. And we should see that basically these numbers have just swapped places, but now things are passing. Yep. So now we've got something that takes about 1/10 of a second, something that takes milliseconds, something that takes, yep. Now we're good. And something else that you can try is, by default, FPM is actually building things with debug flags and no optimization. And so let's see if things are still going to hold when we do some optimizations. Maybe the optimizations actually swap this. I don't know. Again, we got to test all this stuff, because intuitions about how things are going to be performance-wise, once the compiler starts to get a hold of stuff, it's anybody's guess. Well, turns out yes, reading the lines is still, about an order of magnitude, about 2 orders of magnitude faster just reading into an array than it is trying to, construct this string on the fly and reallocate for every line. But our reading into an entire string actually pretty darn close. And actually, occasionally swap places. Well, actually, let's make sure I didn't mix something up. Right? Well, here's something interesting. What happens if we go back to the extra function call? Let's see what happens now. Yeah, now we're still on par. But now, yeah, every once in a while it's going to be just a little bit slower. So is that what we did? Yeah. So somehow this actually gets optimized to the point of not actually being slower. That's an interesting development. We'll have to think about that. But as you can see, so I had an idea that I thought this was going to be the slowest implementation and was just the easiest implementation to go to do. It turned out actually to be the fastest. By testing that, I actually avoided making my library slower. So it's important that you test and measure when you're trying to optimize things. So if you enjoyed this, make sure you get on my email list, like and subscribe to the YouTube channel, or whatever. Make sure you get me some way of getting you notifications when I do more of these videos, because I'm going to be doing a whole lot more. So we'll talk to you again soon.